Good morning, students. This is a lecture of subject textile testing for BTech 6M TT TC students, and the topic is tensile testing terminology. So, in this lecture, we'll try to understand the meaning of these terms: load, breaking load, stress. Now, the first term is load. Now, what is load is basically whenever we stretch a textile specimen in axial direction, a tension is developed inside a tension is developed in the specimen, and we express it in terms of grams or pounds. Now the next is breaking load. Breaking load is the load at which the specimen breaks. Now when we have to compare the strength of two specimen, yarn specimen or fiber specimen, then we need to compare in terms of stress or mass stress or specific stress. Now, what is the difference between these two terms? We need to understand. Stress is basically force, breaking force divided by cross sectional area, and mass stress or specific stress is basically breaking force divided by linear density of the material. Now, these are the two terms we need to understand. That is, whenever we use the term stress to compare, that is stress at break, then it is termed as tensile strength. And whenever we compare specific stress or mass stress, that is breaking load divided by linear density, then we use the term tenacity. Now, we'll understand one more term, which is breaking length. Breaking length is also termed as RKM, and generally it is given in the units of kilometers. Numerically, it is equal to tenacity in gram force per tex. Now, what is the definition of breaking length is? It is a theoretical measure of a specimen of yarn whose weight, I am repeating, it is a theoretical measure of a specimen of yarn whose weight would exert a force equal to the breaking load. So we can say that breaking length is numerically equal to tenacity in gram force per tex. Now the second most important parameter here in tensile testing is extension of the specimen. Whenever we apply load to a specimen, it extends. Now extension can be expressed either in friction, where strain in terms of strain, which is extension upon gauge length, and otherwise in the other way we can express it as in terms of percentage, where we divide extension by gauge length and then express it as percentage. Next two most important terms related to tensile testing is one is modulus and other is work of rupture. Now, what is initial modulus? Initial modulus or Young's modulus is defined as the slope of the load extension curve of any textile specimen in the initial region up to yield point, and it gives us an idea about the stiffness of the fiber or yarn. The second term is work of rupture. Work of rupture is basically the energy required to break the specimen. It is also termed as toughness, and it is area under the load elongation curve, and the unit of work of rupture is unit of load multiplied by unit of extension, which is gram force mm or gram force centimeter. But whenever we need to compare the work of rupture of two yarns or fibers, then we should go for specific work of rupture, which is area under the curve in case of stress strain curve. Now the next term is work factor. Work factor gives us an idea about the nature of the load elongation curve, and it is basically area under the curve divided by breaking load into breaking elongation. So we'll get the value in fraction. In this case, work factor either equal to 0.5 or greater than 0.5 or less than 0.5, depending upon the shape of the curve. Now the next term we'll try to understand is elastic recovery. Elastic recovery is basically elastic extension upon total extension of the material, and elastic recovery is always quoted at a given extension percentage. Now we'll move to the next part of the lecture, that is we'll try to understand the relation between fiber diameter and linear density, assuming fiber cross section is circular. This formula we can apply only in case of circular cross section of the fiber. We know that density is mass upon volume, and volume can be expressed as area and length, area into length. So if we write mass per unit length in terms of linear density, so we get this relation of fiber density is equal to linear density upon pi d square upon 4, which is the area of the circular cross section. And next most important relation we'll study is the relation between tenacity and tensile strength. We have already discussed that tenacity is basically mass stress at break or specific stress at break, which is breaking load upon linear density, and the unit of tenacity is gram per denier or gram force per tex. And tensile strength is stress at break, which is breaking load per unit cross sectional area expressed in units of Newton per millimeter square. Here we'll understand one more, we'll just memorize one more relation, the relation between the units of kilogram force and Newton. We can understand here that F is equal to mg, so 1 kgf is equal to 1 kgf is the force required to pick the mass of 1 kg, which, and the acceleration due to gravity is 9.8 meter per second square. So 1 kgf is equal to 9.8 newtons, or in the other words we can say 1 newton is equal to 102 gram force. Now if we need to convert from tenacity to tensile strength, we can use this relation, as we already know that density can be expressed as linear density upon cross sectional area, and tensile strength is equal to breaking load divided by linear density into density. So we get this relation, that is tensile strength is equal to tenacity into density in appropriate units. Units are very important here. So we'll do some numericals in the next class related to this matter. Thank you very much.